All right, greetings, mathematicians, and I welcome you back to another math lesson. So today, if you can't already tell, we are going to be talking about dividing decimals. So if you are following along in your own spiral notebook at home, here's my updated table of contents, so that way you guys can update it as well. So here we just added dividing decimals, and I'm on page 5. You may not be, and that's okay. Alrighty, so with that, let's go ahead and get into our lesson. So here's my page 5. Our goal for this lesson, well, in this lesson, I will be able to divide decimals using the standard algorithm. And there is one thing that I want to refresh our memories on. Okay, so when you're given a division problem, right, typically we write them like this when we're going to solve them. We have a number underneath. So let's say it's 24. We have a number outside. Okay, and this setup comes from the number sentence that looks like this, 24. Actually, let me stick with the same colors here. Comes from the number sentence 24 divided by 6. Now, if you are very comfortable with where the numbers go when we switch to long division mode, that is awesome. If you're not, hopefully this little vocabulary lesson will help you out here. So, this red number, this 24, we call this is a fancy math term, this is what we call the dividend. This is the number that is being divided. And you'll notice that the dividend goes underneath the division sign. Or we've also talked about this, remember when we were dividing fractions? Whoa! There we go. When we were dividing fractions, the fraction would look like this. I still read this as 24 divided by 6, but we refer to this as a cowboy, right, using the cowboy method. Top number here, this would be the cowboy because the cowboy rides on top of the horse, not the other way around. And this would be our horse. So the cowboy goes inside, the horse stays outside. In formal math terms, we call this top number the dividend, because that's the number that's being divided by something else. The blue number we also have a name for. This is what we call the divisor. This is the number that is doing the dividing. How many times does 6 go into 24? Okay, so you'll hear me refer to the numbers as divisor and dividend a few times throughout this lesson, so just keep that in mind. Alright, so let's take a look at an example here. So let me make an example section. Examples, there we go. Alright, so example number 1. I'm going to divide the decimal 0.24, 24 hundredths divided by 3 and 2/10. So let me underline this here. So this 24 hundredths is my dividend, and 3 and 2/10 is my divisor. So when I set this up, 3 and 2/10, 3 and 2/10 goes on the outside, and 24 hundredths goes on the inside. Okay, so you may or may not remember that we need to make this divisor, my blue number here, we need to make it a whole number. And the way that we're going to do that is we are going to move the decimal. We're going to move the decimal one space over to make this not a 3.2 or 3 and 2/10, we are now going to make it a 32. Do you know how this happened? Does anyone know how this happened? Let me know in the comments if you do know. How did I make 3 and 2/10 into 32? Alright, I'll also tell you about it here. So what's nice is that if I multiply 3 2/10 by 10, I get 32. Okay, we're going to take a look at a few other examples, but our goal, remember, our goal here is to make this 3 2/10 into a whole number, which we did. We made it into 32. Now, whatever you multiply your divisor by, you're also going to multiply the dividend by. So I'm also going to multiply this 24 hundredths by 10 as well. So the decimal is going to move over 1 to the right. So instead of 0.24 or 24 hundredths underneath here, it's going to now be 2.4. Once you have reached this step, you can go ahead and move your decimal straight up. And there we go. And now we can start our long division process. Okay, so 32. How many times does 32 go into 2? No times, right? 32 is way too big. 32. So now we continue to 24. Does 32 go into 24? No, 24 is too small, so we write another 0. Now what's nice is that with decimals, with the numbers, really, you can add zeros and not change the value of the number. So let's take a look. Does 32 go into 240? Yes, it does, right? Let's see how many times. What if I do 32, let's see, 32, what if I do 32 times 6? Let's see what that is. 6 times 2 is 12, 6 times 3 is 18, plus 1, I'm at 192. Can 32 go in one more time? Maybe, let's try it. If I add 32 to this, it's like saying 32 times 7, that's 4, 9 plus 3 is 12, carry the 1, I'm at 224. I think that's our number here. So 32 goes into 247 times. So now let's go ahead and write that down. So 224, and now we subtract. I need to borrow from here, so that becomes a 3, that becomes a 10. 10 minus 4 is 6, 3 minus 2 is 1, and 2 minus 2 is 0. Awesome. So next step, you add another 0, bring it down, and we need to see how many times 32 goes into 160. I know that 32 times 6, you can't see that. I know 32 times 6 is 192. So let's try 32 times 5. Let's see what that is. 32 times 5. 5 times 2 is 10. 5 times 3 is 15, plus 1 is 16. That's exactly what I needed. Perfect. So 32 goes into 165 times. So my answer to this problem, so 24 hundredths divided by 3 2/10 is equal to, let's see, this is my tenths, this is my hundredths, this is my thousandths. So 75 thousandths is my final answer. Now, was that so bad? No, not at all. You guys got this. Okay, let's try another example problem here. This time, there'll be something different. I'm going to do the number. Let's do this one. 476 thousandths divided by 28 hundredths. Now remember, 28 hundredths is our divisor, and 476 thousandths is our dividend. So let's go ahead and set up some long division here. So 28 hundredths is going to go on the outside. And 476 thousandths goes on the inside. Okay, so remember, our goal is to make this 0.28 or 28 hundredths a whole number. If we use the same method we did last time, right? Last time we multiplied by 10. So let's see what happens. If I multiply 28 hundredths by 10, this is what happens. I only get to move the decimal one time. Is 2 and 8 tenths a whole number? Is 2.8 a whole number? Hopefully you said no. So we need to multiply it again by another 10. So that way I can move this decimal point now to the right. So how much did I multiply in total? Hopefully you said 100. So we're going to multiply 28 hundredths by 100. Do you see the connection there? Let me say that again. I'm multiplying 28 hundredths by 100 to make it a whole number. So I move the decimal twice, and this is what happens. So now I have 28 as my divisor. Now, remember, you do the same thing to the dividend. I'm going to multiply my dividend by the same number, by 100, and I move my decimal point 2 times over. So my new, you can't see me, but I'm using air quotes. My new dividend is 47 6/10. Once you've done this, once you've made your divisor into a whole number, and you've changed your dividend as well, you can go ahead and bring your decimal point straight up, and that's where it's going to live. Okay, now here comes the long division part. 28 going into 47. How many times does 28 go into 47? Let's see. Let's try 28 times 2, because I know 20 times 2 is 40, so that should be close. 28 times 2 is 16. 2 times 2 is 4 plus 1. Oh no, that's too much. So 28 goes into 47, not 2 times, but only 1 time. There we go. Okay, so 1 times 28 is 28. Let's subtract these two. I need to borrow. That becomes a 3. The 4 becomes a 3. And my 7 is now 17. 17 minus 8 is 9. 3 minus 2 is 1. And then, of course, I bring down the 6. Let's see how many times 28 goes into 196. Well, 28 times 2 is 56. What if I do 28 times 5? Let's try that. 5 times 8 is 40. Carry the 4. 5 times 2 is 10. Plus 4 is 140. Not quite. I need a little bit more. I'm almost there, though. So maybe let's try 7. 28 times 7. 7 times 8 is 56. Carry the 5. 7 times 2 is 14 plus 5. 14 plus 5 is 19. Hey, there we go. That's what I needed. Okay, so 28 goes into 196 7 times. So I'm going to write 7 above here. 7 times 28 is 196. And we are left with 0. There's nothing else left. So my final answer, so 476 thousandths divided by 28 hundredths is equal to 1 7/10. That is my answer. Okay, let's take a look at another example. I'm running out of room here. Let's move on to the next page. Okay, so this is my page 6, and I'll say dividing decimals continued. There we go. Okay, so this is example number 3. What do I want to do? I want to do, let's try this. We're going to do 4 divided by 1.2. Excuse me, 1 2/10. Practicing my formal decimal reading skills. 1 2/10. Not 1.2, 1 2/10. Alright, so which is my dividend? Hopefully you said 4. 4 is my dividend, so it's going underneath the long division symbol. And then 1 2/10 is my divisor. So let me go ahead and write this as a long division problem. So, see, I caught myself. 1 2/10 goes on the outside, and 4 goes on the inside. Now, is there a way for me to write 4 as a decimal? Think about that for a second. Yes, there is. Remember, if you are ever given a whole number, there's always, always, always a decimal right behind it, and you can add a 0. So we could rewrite 4 as 4.0, or 4 and 0 tenths, or 4 and 0 hundredths, thousandths, 10,000ths, so on and so forth. You can add as many zeros as you want, but I think it might be a good idea to save yourself some time and only use 1 for right now. All right, so do you remember our goal? What's our first step here? Yes, we have to change the divisor into a whole number. How many times am I going to move my decimal to make this a whole number? Hopefully you said, I need to move my decimal once. I need to move it to the right here. So I multiply this by 10. So 1 2/10 times 10 gives me 12. That's my whole number. And then I do the same thing to my dividend. So 4.0, or 4 and 0 tenths times 10, just gives me 40. Oops, let me stick to the same colors here. There we go. And now we have a problem to solve. So 12 goes into 40. If I remember my times tables correctly, 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. So 12 goes into 43 times. So that is 36. Let's subtract. 10 minus 6 is 4, and that's how much is left over. Bring down the 0. 12 goes into 40. Another 3 times. So 12 times 3 is 36. Subtract again. I'm left over with 4. Let's add a 0. Drop it down all the way. 12 goes into 40 3 times again. What is happening here? Do you guys think that this is going to continue on? Do you think I'm going to keep getting 3s over and over? If you said yes, that is definitely correct. This is what we call a repeating decimal in math. So, as my final answer, 4 divided by 1 2/10 is equal to this this number here, 3.333333. You guys said it continued on forever, so I'm just going to keep going. This video might be, I don't know how long this video is going to be, but, yes. You're probably asking, Mr. RG, is there an easier way to write this answer? And I will gladly say, yes, there is. You do not need to write all of these 3s, because that might, we might be ripping our hair out a little bit. So, we have this this notation in math to basically a short way to write it. So what you're going to do is you're going to write the number that repeats. Write the number that repeats and put this nifty little bar right above it. That little bar above it tells me that, hey, that number repeats over and over and over and over forever. Okay, so our final answer looks like this, 3.3 repeating. And there we go. All right, should we look at one more? Let's do one more together. All right, so example number 4 here. I am going to divide this number, 6,678 10,000ths, and I'm going to divide it by 63 hundredths. Think about it. Which one's the divisor? Which one's the dividend? 6,678 10,000ths is our dividend. So that's going underneath the long division symbol. And 63 hundredths, of course, is our divisor. So let me write it as a long division problem. There we go. Okay. First step. What is it? Say it out loud. I can't hear you. Just kidding. Remember, change the divisor into a whole number. How many times do I need to move the decimal here for 63 hundredths? I need to move it 2 times to make it a whole number. So I'm multiplying this side, this guy, by 100. So I have 63 now. I do the same thing to my dividend, the number inside. So I'm going to multiply that by 100. And it behaves the same way. We just move the decimal over 2 times. So now, underneath the long division symbol, I have 66 and 78 hundredths. My decimal just floats straight up. And here we go. All right, 63 goes into 66. How many times? I think we can safely say 1 time. 1 times 63 is 63. Let's subtract. 66 minus 63 is just 3. Let's bring down the 7. Can 63 go into 37? No, 63 is too big, so I'm going to put a 0 here. And that 0 is very important, kiddos. Okay, so 0 times 63 is 0. We subtract. We're still left with 37, but now I'm going to bring down the 8. How many times does 63 go into 378? Oh my goodness. Let's try a few different numbers here. I know that 60 times 5 should be 300. So let's try 63 times 5. Let's see what happens there. 5 times 3 is 15. Carry the 1. 5 times 6 is 30. 30 plus 1 is 31. Hey, not bad. I'm at 315. Maybe I can add one more 63 to this. Let's see. 5 plus 3 is 8. 6 plus 1 is 7. Hey, look at that. That's the number I needed, isn't it? So this is not 63 times 5, but 63 times 6. And that gives me 378 with a remainder of 0. So the answer to this problem, 6,678 10,000ths divided by 63 hundredths is equal to 1 and 6 hundredths. And there you have it. All right, mathematicians. Hopefully this helped you guys out. If you have questions, please feel free to bring your questions to office hours. You can also send your teachers emails. Okay. Also, if you have not subscribed, please subscribe. Like the video if you'd like to. Alrighty. I will see you guys in the next lesson.